What causes Python's floating point inaccuracies? Imagine trying to measure something tiny with a ruler that only has so many marks. You might get close, but never perfectly exact. That's similar to what happens with floating point numbers in Python. When computers store numbers like 0.1 or 0.2, they do so in a way that's not perfectly exact. They use a system called binary, which is just a way of representing numbers with zeros and ones. Python follows a standard called IEIE 750 for storing these numbers. This standard can't precisely representing many decimal fractions because some numbers, like 0.1, have repeating binary patterns that need to be cut off or rounded. When Python converts these decimal numbers into binary, it makes an approximation. So, 0.2 becomes a binary number that's very close but not exactly 0.2. When you add 0.2 and 0.4 in Python, you might expect the answer to be 0.6. But because of these tiny errors, the result could be something like 0.6 quadrillion 1. These small differences happen because the computer has a limited number of bits to store numbers. Usually, floating point numbers use 64 bits, which means they can only store a certain level of detail. If you try to add or subtract numbers with very different sizes, like a very small number and a very large one, the small number's details can get lost. This is called loss of precision. Doing many calculations in a row can also make these tiny errors build up. And if you compare to floating point numbers directly for equality, you might find they are not exactly the same, even if they look identical. To deal with these issues, Python programmers often use functions like round to limit how many decimal places they see. They also use math, isclose, to compare numbers within a small margin of error instead of checking if they are exactly equal. If you need perfect precision, especially for money or measurements, you can use the decimal module. It allows you to work with decimal numbers exactly as you see them, avoiding many of these inaccuracies. So, the main cause of floating point inaccuracies in Python is how the computer converts decimal numbers into binary from using a fixed number of bits. This process introduces tiny errors that can add up or cause unexpected results in calculations. Knowing this helps you write better code and understand why some calculations don't turn out exactly as expected.